All right, so today we're talking about discrete domain and range. Discrete just simply means that we're dealing with lists, so like list of numbers, kind of like this right here. Or if we're looking at a graph, then it's dots. So dots are discrete and lists are discrete. Then the word domain means that it's the x values, okay? And range is the y values. And so the biggest thing with this is just simply learning that domain is x values and range is y values without mixing them up. Number one mistake is, it'll say domain and people want to list the y values, or range and they want to list the x. So the way I remember it is uh, x comes first in the alphabet and then y. So domain comes first in the alphabet and then range. So it's domain is x and range is y. All right, so once we got that down, we'll take a look at this. And today they're asking us not just domain and range, but is it a function, which is good to review as well. So quick reminder that when we're looking at a list of data, that all we care about is the x, okay, and that the x's cannot repeat, okay? So if all the x's are different, then it is a function. So this right here is a function because all the x's were different, okay? And then the domain is just going to be all the x's. So if this was a test, you would list them from, or they would be listed from least to greatest. So it would start with -6 and then, -1, 1, 3, 4. But whenever you're writing it, I don't care. You can just write it the way you see it. So 3, -1, -6, 1, and 4. And then the range is going to be all the y's. So -4, 7, -8, 11, and 13. And that's it. That's your domain and range. And so whenever they're listed out like this, it goes very quickly. Not a whole lot to it. So this should be something that we consider to be easy if you can simply memorize that domain is x's and range is y's. All right, let's take a look at 2. All right, so on this right here, first thing we want to know is it a function? So if we if we draw a vertical line, then right off the bat, this fails the vertical line test. And because it touches 2 dots, remember, it's only allowed to touch 1. So this right here is not a function. Now for the domain, what we're going to do is we're going to go to each dot and we're going to go, domain is x's, we're going to go to the x-axis. So right here's the x-axis. So we're going to go to each dot and go to the x-axis. That's a terrible line right there. All right. Wow, that's real terrible. All right. So we got -1, -2, -3, -4. And then this dot right here also goes to -4. You only have to write it once. If you write it twice, it's not that it's wrong, but you only got to write it once. And then we're just going to every dot and going to the x-axis. So this is 1, 2, 3. And so 1, 2, 3, 4, 5, 6, 7. Okay. And then for the range, we are doing the same thing, except this time we're not going to the x, we're going to the y. So here's the y-axis. So still going from every dot. So here's a dot, but this time we go to the y-axis. So this would be -1, -2, -3, -4. And then there, -1, -2, -3. It doesn't matter the order you go in. I have a particular order I like to go in. That would be 1. And that would be 1, 2. All right. So, hoping this looks really easy. All right, so take a look at this. Is this a function? So remember, when it's listed out, it's that each x is done one time. Well, in this case, it has to have one arrow or one line. Do all these have one line? Yes, they do. So this is a function. We don't care about over here. We just care about the x's. Now for the domain, we're just listing out those x's right there. So 3, -2, and 4. And then for the range, we got 0, -1, and -2. All right. So that's it right there. All right. So next one, we got, so they want to know if this is a function. So I'm going to label all the x's. I told y'all before that if I was trying to tell if this was a function, I would mark off all the y's, but we need that for the range. So I'm just going to label all the x's. Are all the x's different? Yep, they're all down just one time. So this is a function. And then the domain would be all these x's we just looked at. So -1, 5. Oh, that's a terrible 5. 2.3 and 4. And then the range is going to be 9. There's another 9. We only need to write it once. 7 and -2. Okay. So got 4 more of these that we're going to do. All right. So once again, they want to know, is this a function? So are all the x's different? Yes, they're all down just one time. So this is a function. The domain would be the x's. So 5, -1, -2, 1, and 8. And then the range is the y's. So 2, 5.8, 6, 18, and 0. All right. Over here, so definitely these are the tougher ones right here. By the way, I would have called this one number 5. And this would be number 6. Whenever there's a graph, it's definitely tougher. The lists are much, much easier. And so whenever we look at this, first off, is it a function? So we'll draw our lines. Oh, that was terrible. But I can tell that it's not hitting more than once. So yeah, I should draw that one maybe just a little bit better. So anytime I draw a vertical line, it's only touching one dot at a time. So this is a function. All right, and then we got to go to each dot and go to the domain would be to the x-axis. So here's the x-axis, and you can see that they put some dots to go to the x-axis and the y. We are only going to the x first. We can only do one at a time. So this is the x, so -1, -2. And then going down would be -1. And then right here, and that would be 1, 2, 3, 4, 5, 6. All right, and then the range. So with the range, we're not going to the x-axis. We're going to the y-axis. You're still going to every dot, and it doesn't matter which order you're doing this. -1, -2, -3. And then it would be +1. And then right here would be 1, 2, 3, 4, 5. All right. And then Got two more. So just a little bit. All right, so once again, is this a function? We look only at the x's. And if all the x's have one line, then it's a function. And they all do have one line, so this is a function. And then domain is the x's and range is the y's. So domain would be negative 17, negative 125, and 402. And then range would be all the y's. So 80, negative 16, and negative 202. All right, and then last one, is this a function? So we're going to label all the x's. And then I noticed that two of my x's are negative 2's, and they're not allowed to repeat. There's only allowed to be one negative 2. So this is not a function. All right, and then domain. So my first x is a negative 2, and then I got a 2. Then it repeats negative 2, and so I'm not going to repeat it. And then it repeats positive 2, so I'm not going to repeat that one. So this is my domain. And then the range would be 7, 5, negative 2, and 0. All right. So this is the end of the assignment. So you can take a picture and submit it. Today, there are two things you got to do. So one, let me clear all this. So number one, you take a picture and submit it to this right here. And then you also need to take a quiz. Now, on this quiz, for those of you who have not been at home, we don't have our normal calculator. And so you're going to have to use the Desmos calculator. So to find the Desmos calculator, you're going to want to go open up a new tab and type in Desmos, D-E-S-M-O-S, D-E-S-M-O-S, and then calculator. And even if you don't spell calculator right, it'll bring it up because it's the most popular calculator on the web. So we click on this, and this is what it looks like. And so there's two things I want you to know. Number one, if you have a basic equation like 2x plus 4 is equal to 24, then you can do it on this right here like we would in nsolve. You just type in the equation. You don't need to put comma x. You just type it in. And then you have to go look for a vertical line. So I don't see a vertical line. Well, sometimes it's bigger than from 10 to negative 10. So we got to zoom out. And the rule is you zoom out till you see the line or till you get to 1,000. If you get to 1,000, then it's no solution. So we're going to zoom out. Oh, right there it is. And so the answer would be 10. So once you find this vertical line, go down to the x-axis, and there's a dot there. If you just put your mouse over it, then the number will stand out right there. And if you remember, this is called the x-intercept, the 0, and the solution. This is why it's called the solution, is because when it touches the x-axis, that's your answer, okay? And then the other thing is, so I'm going to do something else. Anytime you do something, reload it and get a fresh screen. All right, so if you're asked to do function notation, so we've been doing this on the Inspire, and remember f of x is nothing but y. Oh, what's that? Curly key there. All right, and then it's going to go with the one that's f. So if this says f of 3, in the Inspire, we would hit menu 5.1 and then type 3. And so in this, we're going to do something a little bit different. So in the Inspire, we never put in y equals. In the Desmos, we do have to put y equals if there's a y equals. So I'm going to type this in, y equals x squared plus 7. We'll type that in real quick. So y equals x. Okay, to get the squared, you're going to have to hit right here. And right there's your squared, then plus 7. All right. So notice I don't see a graph. Whether you see a graph or not, it doesn't matter. We're not here for the graph. We want a table. Okay. So when you're doing, we don't have menu 5.1 on the Desmos. So in order to type in the number that we want and to get an answer, we need to go to table. So this Desmos has a table. It's right here where the gearbox is, right here. Okay. So you're going to click on that. And then this right here says convert to a table. It looks like a T table, convert to a T table. All right, so you can't change these numbers, I don't think. But at the very bottom down here, you can type in whatever you want. And the number was 3. So you would type in 3 and then the answer would be 16. So if it was f of 20, and you would type in 20. So 20. And we would get 407, and the answer would be 407. Okay, so that's how you use the Desmos. All right. Well, I hope this helped you guys.